So the directions are the same factor. Okay. Again, what we're going to look for always first is the greatest common factor. That's always what we want to look for. That was the first video. Okay. So we always want to start with this guy, right? The greatest common factor, and then once we recognize there's a common factor and we factor it out, then we take it from there. Okay, sometimes you'll be done in all the examples in the last video we were done with the common factor. Okay, sometimes you'll factor out a common factor and there'll be more work to do, and sometimes there won't be a common factor. Okay, so we'll get into more examples of that, but first what I want to do is recall, okay, or try and remember what we did in the last chapter. Remember that factoring is the opposite of multiplying. So this next case, the difference of squares, I'm going to try and explain that now. So just remember what happens when you multiply something that looks like this. What if I asked you to multiply x minus 3 times x plus 3, what would you get? Well, you would go with the FOIL, but you don't even really have to FOIL, right? With this case, it's x times x gives you x squared. And you can skip the O and the I in FOIL, because the O in FOIL, the two outside terms will give you plus 3x. The two inside terms will give you minus 3x, and they cancel out. Right? So this is that special case of multiplying two binomials where you end up with just these two terms. Okay? So remember, that's what happens when you multiply. So again, in this chapter, we're going backwards. We're going to be given something that looks like this, or we could be given something that looks like this, and we're going to have to recognize it and go backwards. Okay, and that, of course, is called factoring. Okay, so try and make that connection right away. You see, x squared minus 9 is the same thing as x plus 3, x minus 3. All right. So how do you factor that? Well, first of all, you have to recognize that it's the difference of two squares. That's the term for this. Why is it the difference of two squares? Because this is a perfect square. X times x is x squared. Right? A term times itself gives you that. And same thing with this. A number times itself gives you that. 3 times 3. So they're both perfect squares. Okay? So this is what you're going to have to be able to do. Example 1. Say I ask you to factor x squared minus 16. Okay, and I don't want to forget about the greatest common factor now. First thing I do is look for a common factor. In this case, there is none. There's no x in both terms. There's no number that I can divide evenly into both of those. Coefficient here is just 1. Okay, so then I go to step 2, difference of squares, and hopefully I'll be able to recognize this as the difference of squares. So how do you do that? That's a perfect square. That's a perfect square. There's a minus sign in between. What do I mean by perfect square? A number you can take the square root of. I can take the square root of 16. It's 4. I can take the square root of x squared. It's x. Okay. So once you recognize that, maybe make a note of it to yourself. Okay, for our purposes, root x squared is x. Root 16 is 4. Right? If I can't do that, if I can't take the square root of those two terms, then I can't factor it as the difference of two squares. Okay, and of course there has to be a minus sign in between. Let me show you the answer. You take the square root of the first guy, it's going to go here and here. It's always going to be the product of two binomials. Right? And then you take the square root of the second guy, the 16, which is 4, and that goes here and here. And then one gets a minus, one gets a plus. That's it. You don't really have to do any work. It's more recognition, really. Okay, again, you can check your work. Is that the same thing as x squared minus 16? Well, it should be. F in FOIL is x squared. The outside is plus 4x. The inside is minus 4x. That would cancel out, and you'd be left with just the minus 16. X squared minus 16. Okay? Difference of squares. So let's just practice a couple of those. Number 2. How about this? 4x squared minus 25. Again, I look for a common factor. I can't take anything to 4 and 25. There's no x in both terms, so there's no common factor. But if I can recognize the difference of two squares, this is a perfect square, 4x squared, and this is a perfect square. Right? If I can take the square root of it, it means it's a perfect square. Square root of 4x squared. You don't have to do this if you don't want. I'm just showing you how these are perfect squares. Right? This guy times itself gives you 4x squared. 2x times 2x is 4x squared. And of course 25, that one's probably a little easier to notice. Square root of that's 5. Okay? So we recognize what the square roots are, so how do we factor? It's going to factor as the product of two binomials. The first root goes here, 2x, and is repeated over here, 2x. The second root goes here, 5. 5. One gets a plus, one gets a minus, and I'm done. That's it. Let's just do a couple more examples. Give you an easy one. X squared minus 100. Factor. Look for the common factor. There is none. Recognize its difference of two squares because they're both perfect squares and there's a minus in between. Square root of x squared is x. That goes here and here. Square root of 100 is 10. That goes here and here. And you're done. Whoops. And we're done. Notice in this example, the last two examples I did the plus first. In the first two examples I did the minus first. It doesn't matter. X plus 10 times x minus 10 would be the same thing as x minus 10 times x plus 10. Okay? Let's see. Let's do one more example. Call this example number 4. Okay. 2x squared minus 162. X squared minus 162. Directions are to factor. Okay, you'll notice in all these examples I keep repeating myself. The first thing you want to do is find the common factor. Okay, and in this case right now that's all we can do. Because it looks like it might be the difference of squares because there's a minus in between, but this isn't a perfect square. That's a 2. Right? I can't take the square root of 2. Okay, so that's not a perfect square. And 162 is not a perfect square, right? But I always want to do this first. Remember, you always start with this. Always look for that. Sometimes you can, sometimes you can't. In this case, I can factor a 2 out, right? There's a common factor of 2 there, so if I factor out the 2, that gives me x squared minus half of 162. If I factor a 2 out of 162, it should leave me with 81, right? Okay. Now, in the first video, when you did common factors, once you factored out the common factor, you were done. Okay, but sometimes there'll be more to do. Like in this example, we factored the common factor. I go back to my list and say, okay, well, can I do the difference of squares now? Is this the difference of squares? In this case, it is. Right? That's a perfect square. That's a perfect square. There's a minus in between. So the 2 stays where it is, and then I'm going to factor x squared minus 81 as a difference of two squares, which we know how to do now. Square root of x squared, that goes here and here. Square root of 81 goes here and here. One gets a plus, one gets a minus. Okay? And now I know that I'm done. These are not factorable any further. Let's take a look at a kind of a tricky problem that you see sometimes. What if I asked you to factor x squared minus 25x? So again, I'm always going to start with the first step. Look for that common factor. This looks a lot like the difference of squares, but it's not. 25 is a perfect square, but 25x isn't. I can't take the square root of 25x because I can't take the square root of x. But if I don't worry too much about that, just follow the process. A, look for the greatest common factor. If I recognize there's an x in both of these, I factor out the x, and that leaves me with x minus 25, right? Because x times x gives me x squared. X times 25 is 25x. Let me put my equal sign here. I should always include that. I'm going to come down here and replace it. That equals that equals that. Okay. And now I'm done. This is not equal to x plus 5, x minus 5, right? Because there's no squared here. I can't take the square root of x. So in this case, actually, these are both linear factors. At this point, I'm done. I can't do anything else. Okay? Alright, so I think that's enough example. Let's do one more. One more example. How about 6x squared minus 6? The directions, of course, are always just going to be factor. I'm not going to say factor by greatest common factor. I'm not going to say factor by difference of squares. I'm just going to say factor. So you work this process, always look for the common factor. Of course, you can see there's a 6 in this one. Note the difference, by the way, between example 5 and example 6. The part of the common factor for 5, or the common factor for 5, was x, because this second guy had an x term. The second number, rather, had an x attached to it. Number 6, it doesn't. Okay, so I can't factor out an x, but I can factor out the number 6. So I factor that out. So 6x squared minus 6 is equal to 6 times, and then what happens? 6 times what gives you 6x squared? X squared. 6 times what gives you 6? Well, that's 1. Okay, and I've accomplished the first step. I've factored out the common factor. Now be careful. This guy might look like it doesn't go further, but this is in fact a difference of squares. X squared we've seen a lot. I can take the square root of that, right? That's x. What about 1? I can take the square root of 1. It's 1. Okay, so I know that this is the difference of squares. Just this piece right here is the difference of squares. So I'll factor it like that. X plus 1, x minus 1. Okay? So that takes us through the first two processes. Check. First video. Check. That's this video. And then in the next video we're going to talk about ones that look something like this. A 3-term polynomial with x squared, an x term, and a number term. Okay? But for now you got to practice what you've done so far.